Hello everyone, welcome to Pre-Algebra Lesson 6. So in our last lesson, we introduced the concept of exponents and looked at multiple properties of exponents. So in this lesson, we're going to go through a set of exercise problems that involves exponents. Okay, we're going to focus on several categories: the negative exponents, the higher exponents, the zero exponents, the exponents of negative numbers, and then a set of challenge problems toward the end. Now, majority of the problems we're talking about today are compiled from mass counts and AMCA competitions that uses the concept of exponents. So let's get started. Let's look at our first exercise problem: exponents of negative numbers. So for any of the problems that we're going to discuss today, you're encouraged to review the material from last lesson and pause the video and attempt them yourself first. Then you can resume the video and see how these problems are being worked out. So for our first problem, for how many integers n is n cubed between negative 50 and 50? So here, n cubed is lower bounded by negative 50. And we know that any negative number raised to an odd power results in a negative number. So this tells us the range of n is also from negative to positive. So let's first look at n being positive. And let's start with n equal to 1. So 1 cubed equals to 1. That's within the range. Then we have 2 cubed, that equals to 8, also within the range. Then we have 3 cubed equals to 27. That's also within the range. Next we have n equal to 4, 4 cubed. That equals to 64. And 64 is outside the boundary of 50. So we can eliminate that and stop here. Now let's look at n being negative. And let's start with n equal to negative 1. Negative 1 cubed equals to negative 1. Now let's look at n being negative 2. Negative 2 cubed equals to negative 8. That's also within the range. Then we have negative 3 cubed, which equals to negative 27. And you can probably tell by now, negative 4 cubed equals to negative 64. That exceeds our boundary. So that's also eliminated, and we can stop here. Now, some of you are probably asking, what about n equal to 0? That's absolutely right. 0 is also an integer, and 0 cubed equals to 0. Okay. So now here we have the complete range of n from negative to positive, and that is negative 3, negative 2, negative 1, 0, 1, 2, 3. So total of 7 integers for n that satisfies this condition right here. And this is our final answer. Next, let's look at a set of exercises that involves higher exponents. So this problem is asking, express this expression as a power of 5. So in this expression here, there are 5 terms, and they're all identical to each other. So this is simply multiplication. That means we have 5 multiplied by 5 raised to the power of 17. Okay, 5 is equivalent to 5 raised to the power of 1. Then we have multiplied by 5 raised to the power of 17. So from previous lecture, we know that this is equivalent to 5 raised to the power of 1 plus 17, okay, which is 5 raised to the power of 18. And this is our final answer. Let's look at our next problem. How many digits are in the product of 91 and 10 raised to the power of 17? Okay, this number is fairly big, and it can appear quite intimidating. But if we think it through, it's actually pretty simple. So let's see, product of 91 and 10 to the 17, which is 91 multiplied by 10 to the 17. Okay, so this is equal to 91 followed by 17 zeros. 91 followed by a bunch of zeros. And how many zeros are there? 17. Okay, so this is the final product. So here we have 91, which contributes 2 digits. And then we have a bunch of zeros, and there are 17 zeros coming from 10 raised to the 17th power. Okay, so the total number of digits in this product is 2 digits plus 17 digits is 19, which is the final answer. Let's take a look at this problem. When 10 raised to the 93rd power minus 93 is expressed as a single number, what is the sum of the digits? Now take a look here. 10 raised to the 93rd power. That's simply 1 followed by 93 zeros. So let's write that down. We have 1 followed by 93 zeros. So there are a bunch of zeros here. And there are 93 of them total. And then we're going to subtract 93 from this giant number. And the problem is asking what is the result of this subtraction, and then sum up the digits. So let's take the last two zeros and subtract 93 from it. So this resulted in 0 and a 7. Now here there are 91 zeros in the front because we said there are a total of 93 zeros. So when doing this subtraction, it needed to borrow 1 from the previous digit. Since this previous digit is also a 0, it also needed to borrow 1. So that resulted in a 9 here. Okay. But the previous digit also needs to borrow 1 from its previous. So this is also resulting in a 9. So this 9 is trickling forward until it reached the very first digit. Okay. So a 1 is borrowed from the 1 in the first digit. That resulted in a 0. So this 1 is gone. So the result of this subtraction is we have 91 nines here, followed by a 0 in the 7. And now we're going to sum up all the digits. So we have 91 nines plus a 0 plus a 7. That gives us 81 9 plus a 7. And the end result is 826. Let's take a look at this problem. Which of the numbers, these 5 right here, has the greatest value? Now, if you take a look at each of these numbers, their exponents are also exponents. So in the first step, we're going to convert all of these exponents into plain numbers. Okay, so let's start with the first one. We have 2 raised to the power of 3 raised to the power of 4. This is equivalent as 2 raised to the power of 81. Then next we have 2 raised to the power of 4 raised to the power of 3. This is equivalent of 2 raised to the power of 64. Then the third one we have 3 raised to the power of 4 raised to the power of 2. This is equivalent as 3 raised to the power of 16. Then the next one we have 4 raised to the power of 3 raised to the power of 2. This is equivalent of 4 raised to the power of 9. Then in the last one we have 4 raised to the power of 2 raised to the power of 3. This is equivalent of 4 raised to the power of 8. Now when we compare exponents, we either compare them with the same base or we compare them with the same exponent. So here in the first two exponents, we have 2 based. And in the last two exponents, we have 4 base. Okay, so we're going to convert the 4 based exponents into 2 based exponents to help us do the comparison. So this is equivalent of 2 squared raised to the power of 9, which is equivalent of 2 raised to the power of 18. And this is equal to 2 squared raised to the power of 8. This is the same as 2 raised to the power of 16. Okay, so now we have 4 numbers that are 2 based. When the base is the same, the higher the exponent, the larger the number. Okay, so A is the largest, B is the second, then D, then E. Okay, So these are not the largest, and we're going to eliminate them. Now here we're left with C. C is a 3-based exponent. Okay. So in here we're going to try compare with the same exponent. And you can see that the second largest B has the exponent of 64, which is 4 times 16. Okay. So this is equivalent of 2 raised to the power of 4 times 16. Okay. And this is equivalent of 16 raised to the power of 16. So now these two numbers have the same exponent. Okay. When the exponent are the same, the higher the base, the larger the number. Okay. So here B is larger than C. Okay. Since A is larger than B, then A is larger than C. So C is also eliminated. Okay. So here the final answer, A is the largest number. This next few problems will involve zero exponent. So let's take a look at this one first. Let P equal to this expression raised to the power of 2347. And let Q equal to this whole thing raised to the same power. So what is the value of this thing raised to the power of P plus Q? Now if you look at P and Q and look at their base, so you'll notice that if we factor out a -1 out of this expression here in the base, it's essentially the opposite of what's in the base of Q, okay? Because every sign is the opposite from one another. So let's go ahead and do that. Let P equal to, we're going to factor out a -1. So this becomes -1 raised to the power of 2347 multiplied by, because we factor out the -1, so the sign is reversed. So it becomes -2 plus 3 plus 4 minus 7 raised to the power of 2347. So we have -1 raised to an odd power. So we know that equals to -1. So this becomes negative -2 plus 3 plus 4 minus 7 raised to the power of 2347. Okay. Now if you take a look at here, this is Q. That's what's given in the problem. So what this tells us is P is equal to -Q. And that means P plus Q is equal to 0. Now we have that in hand. Let's take a look at what they're asking for. They're asking for 2 plus 3 plus 4 plus 7 raised to the power of P plus Q. Okay. And we know that P plus Q is 0. So this is 2 plus 3 plus 4 plus 7 raised to the power of 0. Now anything raised to the power of 0 is always equal to 1. So this is the final answer, 1. So it doesn't really matter what this base number here is. What matters is the exponent is 0. Let's look at this next problem. Let x be a number. Simplify this expression. Express the answer as number times a power of x. Okay. So we have 6 raised to the 0's power times x squared plus 6 times x squared. Okay. So any number raised to the power of 0 is 1. So we have 1x squared plus 6x squared. So x squared is common in both terms here, so we can factor it out. And what's left is 1 plus 6 inside the parentheses. So this is the same as 7x squared, which is the final answer. In this next set of exercises, we're going to be looking at negative exponents. Let's take a look at the first one. Which of the following numbers is the largest? So here we have 5 exponents. And if you look at their base, they're all related to 2. So as a first step, we're going to convert each exponent into two-based exponent. Okay? So let's start with the first one. We have 1 over 8 raised to the negative 11th power. This is the same as 8 raised to the 11th power. 8 is 2 to the third. The whole thing raised to the 11th power, which is equal to 2 raised to the 33rd power. Okay, let's look at the second one. We have 4 raised to the 16th power. 4 is 2 squared. The whole thing raised to the 16th power, which is 2 raised to the 32nd power. Let's look at the third one. We have minus 2 raised to the 34th power. Okay, this is equivalent as minus 1 raised to the 34th power multiplied by 2 raised to the 34th power. Okay, minus 1 raised to the even power is 1. So this is equivalent to 2 raised to the 34th power. Okay, let's look at the fourth one. 16 raised to the 8th power. 16 is 2 to the 4th. The whole thing raised to the 8th power, which is 2 raised to the 32nd power. Okay, and the last one, we have 2 raised to the negative 4. This whole thing raised to the negative 8th power. Okay, this is the same as 2 raised to the negative 4 multiplied by negative 8th power. And that is equivalent to 2 raised to the 32nd power. Okay. So now we have all these 5 exponents converted to the same base, which is 2. When the base is the same, the larger the exponent, the larger the number. So in here, you can see 34th is the greatest exponent. So C, this number right here, is the largest among the 5. And that's our final answer. Let's look at our next exercise. Let x and y be non-zero numbers. Simplify this expression and express the answer as the power of x times the power of y. Okay, so we start out with x to the 4th multiplied by y to the negative 2. The whole thing multiplied by x to the negative 1 multiplied by y to the 5th power. Okay. So we're going to use commutative property and move things around a bit. So we have x to the 4th multiplied by x to the negative 1 multiplied by y to the negative 2 multiplied by y to the 5th power. Okay. Now we're going to combine exponents with the same base together. And this gives us x to the 4 plus negative 1, which is 4 minus 1, multiplied by y raised to the power of negative 2 plus 5. Okay. So this is the equivalent of x to the 3rd multiplied by y to the 3rd. And that is our final answer. So in this next problem, it's asking to evaluate the value of this expression if x is equal to 1 and y is equal to negative 1. So we're going to substitute these numbers in for x and y respectively. So what we have is 15 multiplied by 1 squared multiplied by negative 1 to the negative 3 plus 18 multiplied by negative 1 multiplied by 1 to the negative 1 plus 27 multiplied by 1 multiplied by negative 1 raised to the 4th power. Okay, so in here we have 1 squared is 1, so that's 15 times 1, which is 15. Negative 1 raised to the negative 3 power is basically negative 1 raised to the 3rd power, which is negative 1. Okay, so what we have is 15 multiplied by 1 multiplied by negative 1. And then here we have 18 multiplied by negative 1. 1 raised to the negative 1's power is the same as 1 raised to the 1's power, which is 1. Okay, and then we have 27 multiplied by 1 multiplied by negative 1 raised to an even power is 1. Okay, so the first term becomes negative 15. The second one becomes negative 18, which is minus 18. And the third is 27. Okay, So we have negative 33 plus 27. And the final answer is negative 6. Let's look at this next exercise problem. Let a and b be non-zero numbers. Simplify this expression. Write the answer as a number times the power of a times the power of b. So let's first write down the expression. We have 6 times a squared times b, the whole thing raised to the power of 2, divided by parentheses 3 times a squared times b cubed, close parentheses. So in our first step, let's remove this first pair of parentheses. And this resulted in 6 squared multiplied by a raised to the power of 4 multiplied by b squared. Let's also remove the second pair of parentheses. This becomes divided by 3 divided by a squared divided by b cubed. Next, let's rewrite the 6 as 2 times 3. So the 3 term can be combined with this 3 right here. So 2 times 3 raised to the power of 2 is the same as 2 raised to the power of 2 multiplied by 3 raised to the power of 2. Then we have multiplied by a raised to the power of 4 and multiplied by b squared. Divided by 3 is the same as multiplying 3 raised to the power of negative 1. Next, we have divided by a squared, which is multiplying a raised to the power of negative 2. And last, we have multiplying b raised to the power of negative 3. So in this next step, let's combine the exponents that has the same base together to simplify. So first we have 2 squared, which is the only term that is base 2. So this stays as is, 2 squared. Multiplied by 3 squared is going to be combined with 3 raised to the power of negative 1. And this gives us 3 raised to the power of 2 minus 1. Then we have a raised to the power of 4 combined with a raised to the power of negative 2. That gives us a raised to the power of 4 minus 2. Then we have b squared combined with b raised to the power of negative 3. And this becomes b raised to the power of 2 minus 3. Okay. Next, let's simplify. 2 squared is 4. Multiplied by 3 raised to the power of 1, which is 3. Multiplied by a squared. Multiplied by b raised to the power of negative 1. And this whole thing becomes 12a squared b raised to the power of negative 1. And this is our final answer. Next, we have a set of challenge problems. Let's look at this first one. Express this expression as a power of 2. So if you take a look at this expression, each of the term, their base is a power of 2. So we're going to rewrite each one with the base converted into a power of 2 exponent. So the first one stays as is, 2 squared. Then multiplied by 4 is the same as 2 squared, the whole thing raised to the power of 2. Next, we have 2 cubed, the whole thing raised to the power of 2. Then next, we have 2 to the 4th, the whole thing raised to the power of 2. And then multiplying so on and so forth till the last term, we have 2 to the 10th raised to the power of 2. So next, let's take off all the parentheses. So it becomes 2 squared multiplied by 2 to the 4th multiplied by 2 to the 6th multiplied by 2 to the 8th, and then so on and so forth until the last term we have 2 to the 20th. Now all the exponents here are 2 based, so we can combine them together. This becomes 2 raised to the power of 2 plus 4 plus 6 plus 8 plus so on and so forth till the last term, which is 20. So in our next step, we need to solve this expression. So we need to solve what is 2 plus 4 plus 6 plus 8 plus so on and so forth plus 20 equals 2. Okay. So we have done similar problems before. So in here, the first term added to the last term is 22. If we take the second term and add it to the second to last term, the sum is also 22. So each pair, the sum is 22. And then in this expression here, there are 5 pairs. So it's 22 times 5, which is 110. So this whole thing is equal to 2 raised to the power of 110. And this is our final answer. Let's look at this next challenge problem. What is the sum of digits of the number 2 raised to the power of 2005 times 5 raised to the power of 2007 times 3? So if you look at the first two terms here, we have 2 times 5 is equal to 10. So if we can make the exponent the same, then we can combine these two terms together. And let's look in that direction. So we start out with 2 raised to the power of 2005. And then multiply by 5 raised to the power of 2007. This is the same as 5 raised to the power of 2005 plus 2. And then multiply by 3. Okay. So here we have 2 raised to the power of 2005 multiplied by 5 raised to the power of 2005 multiplied by 5 squared multiplied by 3. Okay. So these two can be combined together, which is 10 raised to the power of 2005. And then 5 squared is 25 times 3 is 75. Okay. So the number we have is essentially 75 followed by 2005 zeros. Okay. So this is 75 followed by a bunch of zeros. And there are 2005 of them. So this is the final product. If we sum up the digits, we literally have 7 plus 5 and then plus a bunch of zeros, which the sum is 12. That's our final answer. Okay, let's look at our final challenge problem. What is the value of x in this equation right here? So if you notice, on the left-hand side, we have a term that's an exponent with a base of 30. So on the right-hand side, we want to combine all of these terms and also derive a exponent with base of 30. So we can see what's left over so we can match up to this term, which is a exponent that's 2-based. Okay, so let's go in that direction. So let's start with our right-hand side. Okay, we have 2 to the third multiplied by 3 to the third multiplied by 4 to the third multiplied by 5 to the third. So they're the same exponent. We can combine them, becomes 2 times 3 times 4 times 5, the whole thing raised to the power of 3. Okay. So you can already see that 2 times 3 times 5 is 30. So we have a base of 30 here. Let's group them together. So we have 2 times 3 times 5 raised to the power of 3. And then we have 4 raised to the power of 3. What's left over? Okay. So this is 30 raised to the power of 3 multiplied by, we want to write the 4 into a 2 base. So that becomes 2 squared raised to the power of 3. So this gives us 30 raised to the power of 3 times 2 raised to the power of 6. Now we're going to make our left-hand side equal to our right-hand side. Okay. So the equation becomes 2 to the x times 30 raised to the power of 3 is equal to 2 to the 6 times 30 raised to the power of 3. Okay. So here you can see, to make these two the same, x must equal to 6. And this is our final answer. Okay, so this concludes our lesson for today. Feel free to review the materials from our previous lesson on exponents and property of exponents, and feel free to rework out any of the problems we discussed today and get yourself familiarized with exponents. And we'll see you next time.